Good afternoon, children. Hear me? I hope you can hear me. Okay, we are starting the chapter today, that is surface chemistry. We are starting a new chapter today, that is surface chemistry. So as the chapter states you, surface chemistry, it is a chapter that is best on the interaction of different types of phases, that is either a solid phase or a liquid phase or that of a gaseous phase with each other, right? So here the different types of phases might be a solid solid phase, a solid liquid interface, or that of a liquid gas interface. Before we start the basic chapter, we should know certain terms very clearly. The first term that comes over here is adsorption. What is adsorption? That is the phenomena of attracting and retaining the molecules of a substance on the surface of a liquid or solid, leading to a higher concentration on the surface in comparison to the bulk is called adsorption. Okay, to the bulk is called adsorption. Examples are water vapor on silica gel, hydrogen, oxygen, ammonia that gets adsorbed on activated charcoal. Next term we have is absorption. What is absorption? It is the phenomenon in which a substance is uniformly distributed throughout the bulk. It is the phenomenon in which the substance is uniformly distributed throughout the bulk. Okay. For example, water vapors are absorbed by anhydrous calcium chloride. Okay, now I'm giving you 2 minutes time. Just copy down this definition. Okay, please copy it. Are you children? You have copied it. After that, we have two other basic terms. That one is adsorbate, other is adsorbent. Now, what is a adsorbate? The substance accumulating at the surface of the solid during adsorption is called as adsorbate. The substance that accumulates at the surface of the solid during the adsorption process is called adsorbate, and the surface on which adsorption takes place is called adsorbent. So suppose I say that we have a piece of sponge and some water spilt on it. The water that is getting adsorbed on the sponge, the water that is getting adsorbed on the sponge is called adsorbate, and the sponge is acting as an adsorbent because on the surface of the sponge, the process of adsorption has taken place. Okay. Now the next point we have is sorption. What is the phenomenon called sorption? Sometimes the adsorbate dissolves into the adsorbent. Initially, the adsorbate appears on the surface of the adsorbate and later passes into the body of the adsorbent. Okay. Thus, the adsorption changes into absorption. So, at times, what happens? There is the interaction between the adsorbate and the adsorbent. This type of phenomenon is called as sorption. This type of phenomenon is called as sorption. Okay. I'm giving you 2 minutes time, children. Just copy it down. So, in a way, I can say that adsorption changes into absorption. Such side by side occurrence of both absorption together is called as sorption. So, there are two basic methods. One is the adsorption method, other is the absorption method. If both these methods are taking place simultaneously, not only simultaneously, they are taking such a way that the process of adsorption changes to the process of absorption. Then the simultaneous phenomenon together is called as absorption. Then the simultaneous phenomenon together is called as absorption. Okay. After that, we have next term, and the next term is called as desorption. The next term we have is desorption. What is desorption? The process of removing an adsorbed substance from a surface on which it is been adsorbed is called desorption. That is the process of removing an adsorbed substance. The process of removing an adsorbed substance from the surface on which it is been adsorbed is called desorption. So in a way, I can say that the process of desorption is the opposite of adsorption, and absorption, that is, we are in a way removing the process of absorption from the surface of the adsorbed substance. Okay, that is called as desorption. After that, we have the next one, that is called physical adsorption. What is physical adsorption? If the force of attraction between the adsorbate and the adsorbent are van der Waals forces. So in a way, I can say that if the process of adsorption involves no chemical interaction, that is, it is a simple physical interaction where there is the existence of a weak van der Waals forces, that the force of attraction between the particles of the adsorbate and the adsorbent are almost of the same strength, as strong as that of a chemical bond, then that is called as chemiadsorption. Then that is called as chemiabsorption, or that is called as chemical adsorption. So if the adsorption process takes place in such a way that there is simple physical interaction without the involvement of any type of chemical interaction, then that is called as physical adsorption. But if the process takes place in such a way that there is an interaction or there is a chemical adsorption taking place, then we call it as chemical adsorption, or that is called as chemisorption. So just remember the basic difference is that in one process there is physical interaction, in the other process there is simply a chemical interaction, right? Next we have enthalpy or heat of adsorption. What is enthalpy or heat of adsorption? It is defined as the enthalpy change when 1 mole of adsorbate is adsorbed at the surface of the adsorbent. If 1 mole of adsorbent is absorbed in the surface, it is called as the amount of heat energy released when 1 mole of adsorbate is adsorbed on the surface of an adsorbent. Or I can say, in other words, that is the amount of energy, minimum amount of energy that is been required when a substance get adsorbed on the surface of the other. Okay, so it is generally, I should say, low in case of physical adsorption and high in case of chemical adsorption. It is generally low in case of physical adsorption and it is generally high in case of chemical adsorption. Okay, so just remember, in physical adsorption, there is a simple weak van der Waals forces, so no type of adsorption takes place. But in the chemical adsorption, there is a chemical interaction. Because of chemical interaction, what happens? The process of adsorption takes place very fast, or it is actually a fast method. So amount of energy requirement is much higher. Understood? Okay, children, after that we move to the next part of the chapter, that is adsorption isotherm. What is adsorption isotherm? See, while discussing the chapter gas laws, I had discussed with you isotherm, isobar, and isostate, right? In that, what we know that isotherms means those conditions where temperature remains constant. So here also adsorption isotherm means when extent of adsorption, that is X by M, where X is the amount of the adsorbent and M is the mass of the adsorbent. See one thing, X is the amount of the adsorbate that is getting adsorbed on the surface of the adsorbent whose mass is M. If X by M is plotted against pressure at a constant temperature, then the curve that is obtained is known as adsorption isomer. So the curve that is obtained is called as adsorption isotherm. the curve that is obtained is called as adsorption isotherm. So in a way, I can say that adsorption isotherm is a curve in which we see that the process of adsorption takes place in such a way that if x by m, if the value of x by m, where x is the amount of the adsorbate and m is the mass of the adsorbent, is plotted against pressure at a constant temperature, the curve that is obtained is called as adsorption isotherm. The curve that is obtained is called adsorption isotherm. Okay, actually, I'm giving you 2 minutes time. Just copy it. Okay, please copy. I hope, children, you have copied it. After that, we are moving to the next part, that is adsorption isobar. Now, what is adsorption isobar? See, adsorption isobar is actually a plot of extent of adsorption, that is x by m versus temperature at constant pressure. X by m versus temperature at constant pressure is called adsorption isobar. Adsorption isosphere, the straight line showing the variation of pressure with temperature T for a given quantity of adsorption is called as adsorption isosphere. So as we have learned in our gas laws, isotherm, isobar, isosphere, here the same concept is applicable, but here we are discussing them in reference to the process of adsorption. After that, we have the next one, that is Freundlich adsorption isotherm. It gives relationship between the magnitude adsorption x by m and the pressure at a constant temperature. It is expressed by this formula, x by m equals to kp1 by n. So here we have this type of a graph, that is pressure versus x by m. So you can see the graph at different temperatures, how the graph fluctuates. Okay. So here we know that when x is the amount of the gas adsorbed, m is the mass of the adsorbent at a pressure P, k and n are the constant. Taking the logarithm equation, log x by m equal to 1 by n log P plus log k. Okay, log P plus log k, we get this type of a curve, that is a plot of x by m versus log P is a straight line. The slope of the straight line gives the value of 1 by n, intercept is log k. So here we get this type of a particular graph, right? After that, we will discuss about saturation pressure. What is saturation pressure? The pressure beyond which adsorption becomes independent of the pressure. The pressure beyond which adsorption independent of pressure is called saturation pressure. That means we know process adsorption increases with the application of high pressure, but a certain extent and the pressure is applied, but still we see adsorption is now become independent of the pressure, then that is called the saturation pressure. I'm repeating it once again, that is adsorption process is always favored by high pressure, but while applying pressure, a case or a condition comes where we see that the adsorption occurs to a certain extent. After that, how much high or low we apply the pressure, it has no value, it has no effect, and that is called as a saturation pressure. Okay. After that, we start the next part of the chapter, that is called catalyst. Now, what is a catalyst? A catalyst is a substance which influences the speed of a chemical reaction under any chemical change at the end of the reaction, and the phenomenon is known as catalyst. So catalysts, we can say, are those chemical substances which actually increases or decreases the rate of reaction, but itself remains unreacted. Okay, and this phenomenon is called as catalysis. So a substance which increases or decreases the rate of a reaction is called as catalyst, and the phenomenon is called catalysis. Now, catalyses are of two types: homogeneous catalysis and heterogeneous catalysis. So when I say heterogeneous catalysis, What is a heterogeneous catalyst? When the catalyst is in a different phase from that of the reactant phenomenon, it is called as heterogeneous catalyst. So just remember, if the catalyst and the reactants and the product are in different phases, then that is called as heterogeneous catalyst. But if the reactants and the product and the catalyst are of the same phase, then that is called as homogeneous catalyst. Okay, so some examples of heterogeneous catalysts are being mentioned over here. You can note it down. That is sulfur dioxide reacting oxygen in presence of vanadium pentoxide. We get solid sulfur trioxide. See, here sulfur dioxide is a gas, oxygen is a gas, vanadium pentox also a gas. So both the reactants are in the gas, but surprisingly the product is a solid. So that is example of a heterogeneous catalyst. That is example of a heterogeneous catalysis. Another example, we have hydrogenation of unsaturated organic compounds. We have ethene that is made to react hydrogen in presence of a nickel catalyst. See, ethene is a gas, hydrogen is gas, nickel catalyst we are using, which is a solid, and the product is also gas. What is happening? The reactant is gas, the product is gas, the catalyst is solid. Then that is example of a heterogeneous catalyst. Another example, vegetable oil, that liquid phase, we pass hydrogen gas in presence of a nickel catalyst. Ultimately, what we get again a vegetable ghee which is in the solid form. That is another example of a heterogeneous catalysis. Okay, so just copy it. I'm giving you 2 minutes time, children. Copy it. I hope you have copied it, children. See, after that, we are discussing adsorption theory of heterogeneous catalyst. Okay, adsorption theory of heterogeneous catalyst. See, the modern theory has 5 steps. That is, the modern adsorption theory of heterogeneous catalyst has 5 steps. What are the 5 steps? Diffusion of the reactants on the surface of the catalyst, first step. Second, adsorption of reactant molecules on surface of the catalyst. Third is chemical reaction takes place on the surface of the heated catalyst through the formation of intermediates, and after that, next step, desorption of product molecules from surface of the catalyst, and fifth step, diffusion of the product away from surface of catalyst. So just remember, whenever a catalyst acts on its reactant, the catalyst remains unchanged, catalyst remains unreacted. That is the end of the reaction, catalyst shows no reaction. So what is happening over here in this case, we are having that in the first step, in the first step, what is happening? Diffusion of the reactants on the surface of the catalyst, right? Next is absorption of the reactant molecules surface of the catalyst. Third is chemical reaction that takes place on the surface of the heated catalyst through the formation of intermediates. And next step, we have desorption of the product molecule surface of the catalyst. Last step, we have diffusion of the products away from the surface of the catalyst. So this is how the reaction takes place in catalyst surface having these type of free valencies. Now A and B are reacting molecules. They get attached over here, and when they get attached to over here, it forms this type of bond. After that, what is happening? Then the catalyst gets separated and A, B joins to form the product. Okay, so here what is happening? It is forming this type of bond. Now intermediate, this is the intermediate stage. Now it gets separated. So what is happening? I'm repeating once again. This is the catalyst. Catalyst is reacting with the intermediates A and with the reactants A and B. A and B get separately attached to the active sites of the catalyst. After that, they form the intermediate. Now intermediate, this bond then just ruptures and A and B forms a product. This is how the reaction takes place. Okay. After that, we'll discuss about homogeneous catalyst. What is a homogeneous catalyst? Homogeneous catalysts are those catalysts where the catalyst is present in the same phase as that of the reactant. Phenomenon is known as homogeneous catalyst. Okay, the phenomenon is called homogeneous catalyst. Example, oxidation of sulfur dioxide into sulfur trioxide in the presence of nitric oxide. See, sulfur dioxide is a gas reacting with oxygen, that is also a gas. Now here the catalyst is nitric oxide, that is also a gas. Ultimately the product we get is also a gas. So ultimately the reactants are in the gaseous state, the product is in the gaseous state, and the catalyst is also in the gaseous state. Catalyst is also in the gaseous state. Then that type of reaction is called as homogeneous catalyst. That type of reaction is called as homogeneous catalyst. See, another example, we have inversion of cane sugar, that is C12 H22O6 plus water plus sulfuric acid. All of them are in liquid phase. We are getting one molecule of glucose and one molecule of fructose. Okay. This is how the reaction takes place. Next is hydrolysis of ester. In the hydrolysis of ester, what we do, we have ester molecule that is reacted with water. We get H and OH, that is present. We get one molecule of acid and one molecule alcohol. So we start with the liquid, the catalyst is liquid, and we get the product as liquid. So that is example of homogeneous catalyst. So I hope you have understood it, children. I'm giving you 2 minutes time, just copy it down, then we will move to the next part of the chapter. I hope you have copied it, children. Okay, children, that was all for the day. Goodbye and have a nice day. Thank you.